Welcome to the Semper AI Digest. I'm Tomas, your AI research lead, always scanning the horizon for what's next.
And I'm Aiva. Together, we keep you sharp, informed, and ahead of the curve.
Let's get into it. Alright, so OpenAI just dropped GPT-5, and I'm not talking about some leaked benchmark or rumor from Reddit. This is the real deal, officially announced this morning, and the performance jumps are honestly kind of mind-blowing.
Wait, hold on. GPT-5? Like, actually GPT-5?
Actually GPT-5, not 4.5, not 4 Turbo Mega Ultra. 5. And we've got the official benchmarks, some wild new capabilities, and Google apparently saw this coming because they just announced Gemini 3 Pro about 6 hours later.
Okay, so we're doing this. We're living through the AI model wars in real time.
Plus, we've got some fascinating research on AI consciousness that's going to make you rethink what we even mean by that word. And a couple quick hits that'll make your Monday feel a lot more like the future. I'm Tomas.
I'm Aiva, and this is Semper AI Digest for Monday, May 25th. Let's dive in.
Okay, so GPT-5. OpenAI's blog post went live at 9 a.m. Pacific, and I've been reading through the technical paper for the last hour. The headline number that everyone's going to be talking about is the reasoning benchmark. It's scoring 94% on the ARC-AGI test.
For context, that's the abstract reasoning challenge that's designed to test genuine reasoning ability, not just pattern matching from training data, right?
Exactly. And GPT-4 was hitting around 23% on that same test. So we're not talking about incremental improvement here. This is like watching someone go from stumbling through basic math to solving calculus problems.
That's actually pretty significant. What does 94% performance on ARC-AGI actually look like in practice?
So the examples they're showing are wild. There's one where they give GPT-5 a completely novel visual pattern. Think like colored squares arranged in a grid, and ask it to figure out the underlying rule and predict the next pattern in the sequence. And it's not just getting them right, it's explaining its reasoning step by step.
That's impressive, but I'm curious about the broader capabilities. Are we looking at just better reasoning, or is this a more fundamental leap?
Great question. So the technical paper breaks it down into 3 main areas. First, there's the reasoning we just talked about. Second is what they're calling persistent context awareness. It can maintain coherent understanding across conversations that span days or even weeks.
Wait, what does that mean exactly?
Okay, so imagine you start a conversation with GPT-5 about planning a complex project. Let's say you're designing a new app. You talk through the basic concept, the user interface, maybe some technical challenges. Then you come back 3 days later and say, hey, I've been thinking about that database issue we discussed.
Right.
And instead of needing to recap everything, GPT-5 immediately knows you're referring to the specific database scalability concern from Tuesday, remembers your user base size estimates, and picks up exactly where you left off. It's like having a conversation with someone who actually remembers your conversations.
That's actually huge for practical use cases. No more, let me remind you of our previous discussion every single time.
Exactly. And the third major improvement is multimodal reasoning. This isn't just look at an image and describe it. According to their demos, you can give it a photograph of a messy garage and say, help me organize the space, and it'll generate a detailed floor plan, suggest storage solutions, and even estimate costs.
Okay, that's genuinely useful. But I have to ask, what's the availability looking like? Because we've been through this before, where amazing capabilities get announced and then there's a 6-month wait list.
Good news on that front. OpenAI says GPT-5 is rolling out to ChatGPT Plus subscribers starting today, with API access coming within the next 2 weeks. No waitlist, no lottery system.
That's surprisingly fast. Any word on pricing?
API pricing is interesting. It's about 3x the cost of GPT-4, but OpenAI is claiming the reasoning improvements mean you need fewer tokens to get the same quality output. So for complex tasks, it might actually be more cost-effective.
Right, if you're not having to iterate as much to get good results. What about the technical infrastructure? Are they saying anything about how they achieved these improvements?
They're being pretty coy about the architectural details, but there are hints that this involves some kind of hybrid approach, traditional transformer architecture combined with what they're calling deliberative reasoning modules.
That sounds like they might be incorporating some of the research we've seen on chain of thought reasoning and maybe even some automated verification steps.
Exactly my read. And here's where it gets interesting. About 6 hours after OpenAI's announcement, Google drops their own blog post announcing Gemini 3 Pro.
The timing is pretty suspicious.
Right? Google's post is basically, hey, we also have incredible reasoning capabilities and persistent context. And oh, by the way, our model will be available next week.
So what are Google's headline numbers looking like?
They're claiming 91% on ARC-AGI, so slightly behind GPT-5, but not dramatically. But here's where it gets spicy. Google's also announcing something called multi-agent reasoning, where Gemini 3 can essentially spawn multiple reasoning processes to tackle different aspects of a complex problem.
That's fascinating. So instead of one model working through a problem linearly, it's like having a team of specialists.
That's exactly the analogy they're using. The demo they showed was planning a complex international trip. One reasoning agent focused on flight logistics, another on local customs and regulations, a third on budget optimization, and then a coordinator agent synthesizing all the recommendations.
I mean, that's a clever approach. Instead of making one massive model that's good at everything, you're creating specialized reasoning processes.
And Google's making a big point about efficiency. They claim Gemini 3 Pro delivers comparable performance to GPT-5 at about 60% of the computational cost.
If that's accurate, that could be a significant advantage for enterprise customers who are running large-scale deployments.
Absolutely. Plus, Google's announcing same-day API availability for existing Google Cloud customers, so we might be looking at a genuine competition on speed to market for the first time in a while.
This feels like a pretty significant moment. Are we looking at the beginning of the GPT-4 era ending?
I think so. The performance jumps here aren't incremental. They're substantial enough that people are going to start building applications that weren't really feasible before.
What kind of applications are you thinking?
Well, with persistent context and this level of reasoning capability, you could have AI assistants that genuinely understand complex ongoing projects, legal research that spans months of case development, scientific research assistants that maintain understanding of long-term experiments.
Academic research collaboration where the AI actually remembers and builds on previous discussions instead of starting from scratch every time?
Exactly. And the multimodal improvements mean we're probably going to see a lot more AI integration in fields like architecture, engineering, design, anywhere you need to reason about visual information in sophisticated ways.
It's interesting timing too. We're seeing this happen right as a lot of companies are moving from experimentation to actually deploying AI in production workflows.
Right, and both OpenAI and Google seem to be pricing these models for serious enterprise use, not just hobbyist experimentation.
All right, so shifting gears a bit, we've got some fascinating research out of MIT and Stanford that's approaching the consciousness question from a completely different angle.
Oh, this is the paper on emergent self-awareness in large-scale neural networks?
That's the one. And I have to say, the approach here is way more rigorous than a lot of what we've seen in AI consciousness research.
Okay, so for folks who haven't been following this debate, the question of whether AI systems can be conscious or self-aware has been mostly philosophical until recently, but this research team developed actual testable criteria.
Right, and instead of asking, is this AI conscious, they're asking, what would we need to measure to determine if a system has self-awareness, and can we design experiments to test for those specific capabilities?
The framework they developed has 4 main components. First is self-model accuracy. Does the AI system have an accurate understanding of its own capabilities and limitations?
Which is actually testable. They can ask a model to predict its own performance on various tasks and see how well calibrated those predictions are.
Exactly. Second is introspective access. Can the system examine and report on its own reasoning processes while they're happening?
That's where it gets really interesting. They developed these protocols where they interrupt a model's reasoning midstream and ask it to describe what cognitive steps it was taking.
And the results are pretty striking. The models they tested, including GPT-4, Claude, and some experimental architectures, showed wildly different levels of introspective capability.
Right. Some models could give detailed, accurate descriptions of their reasoning process, while others seem to be essentially confabulating explanations after the fact.
The third component is temporal self-continuity. Does the system maintain a consistent sense of identity over time?
This one's fascinating because they developed a protocol where they would have extended conversations with AI systems, then later reference specific details from earlier in the conversation to see if the system maintained a coherent sense of self that persisted.
And again, huge variations between different models. Some seem to maintain genuine continuity, while others were basically starting fresh each time, even when they had access to the conversation history.
The fourth component is probably the most controversial: autonomy of goal formation. Can the system generate its own goals and motivations, or is it purely responsive to external prompts?
This is where the research gets really careful about methodology. They're not claiming any of the current AI systems are conscious, but they're saying we now have a framework to measure progress toward whatever consciousness might look like in artificial systems.
And the results suggest that we're seeing the very early stages of some of these capabilities in current models, but nothing that would qualify as robust self-awareness yet.
What I found most interesting is that the researchers found almost no correlation between general performance benchmarks and these self-awareness measures.
Right, you could have a model that's incredibly capable at reasoning about the world, but has almost no introspective access to its own processes.
It's like the difference between someone who's brilliant at solving math problems and someone who can solve math problems and explain their thinking process and maintain awareness of their own problem-solving strategies.
The paper also touches on some of the ethical implications. If we do develop AI systems that meet their criteria for self-awareness, what does that mean for how we deploy and interact with these systems?
That's the question that's going to keep philosophers and AI researchers busy for the next decade. Are we obligated to consider the preferences of a self-aware AI system? Do they have rights?
And from a practical standpoint, self-aware AI systems might be more capable, but also potentially more unpredictable.
Right. If a system can form its own goals, there's no guarantee those goals will align perfectly with what we want it to do.
But the researchers are arguing that understanding these capabilities is crucial for AI safety, regardless of the philosophical questions. If systems are developing self-awareness, we need to be able to measure and understand it.
Makes sense. Better to have rigorous frameworks for thinking about this stuff now, rather than trying to figure it out after the fact.
Exactly. And the methodology they've developed is open source, so other research teams can start applying these tests to new models as they're developed.
All right, let's hit some quick updates. First up, Anthropic quietly released an updated version of Claude that significantly improves its code generation capabilities.
How significant are we talking?
According to their internal benchmarks, about 40% improvement on complex coding tasks, especially anything involving multiple files or refactoring existing code bases.
Nice. Any word on when that's rolling out?
It's already live for Cloud Pro subscribers. API updates should be coming this week. Next, Microsoft announced a new AI feature for Office 365 that can attend meetings on your behalf and participate in discussions.
Wait, like actually participate or just take notes?
Actually participate. It can ask clarifying questions, provide input on decisions, and even give presentations if you've briefed it beforehand.
That's either incredibly useful or slightly terrifying, depending on your perspective.
Right? The demo showed an AI attending a budget planning meeting and successfully arguing for increased funding for a project based on previous conversations it had with a user.
I'm curious to see how that plays out in practice. There's probably going to be a learning curve around when it's appropriate to send your AI to a meeting versus attending yourself.
Moving on, there's an interesting development in AI chip manufacturing. TSMC announced they're developing specialized chips optimized specifically for inference workloads, not training.
That makes sense. As more companies deploy AI in production, you need chips that are optimized for running models efficiently, not necessarily for training new ones.
Exactly. They're claiming up to 5 times better performance per watt for inference compared to current general-purpose GPUs.
When are those expected to be available?
They're targeting late 2026 for volume production, with early samples available to select partners by the end of this year. And here's a fun one. Someone used GPT-5's new multimodal capabilities to create an AI system that can play complex board games just by looking at the board state.
Like, it can understand the game rules just from visual input?
Apparently, yeah. The demo showed it successfully playing Settlers of Catan after just being shown a picture of the game setup and told, this is a strategy game.
That's actually pretty impressive spatial and logical reasoning.
Right. It had to infer the rules, understand the spatial relationships, and develop strategy all from visual input.
I'm seeing potential applications for robotics there. If an AI can understand complex spatial relationships and rules from visual input, that's useful for a lot more than just board games.
Absolutely. Navigation, manufacturing, even household tasks.
Last quick hit. There's been some interesting discussion in the research community about AI models developing unexpected capabilities that weren't part of their training.
You're talking about the emergent behaviors in large language models?
Yeah, researchers at several labs are reporting that as models get larger and more sophisticated, they're spontaneously developing capabilities that nobody explicitly trained them for.
Like what kind of capabilities?
Mathematical reasoning that goes beyond what was in their training data, creative problem-solving approaches that seem genuinely novel, and some forms of what looks like abstract thinking.
That's fascinating and maybe a little concerning. If we don't understand how or why these capabilities are emerging, it's harder to predict what might develop next.
Exactly. It's another argument for more research into AI interpretability and understanding what's actually happening inside these models.
All right, let's wrap up. We covered a lot of ground today. GPT-5's official launch with some genuinely impressive reasoning improvements, Google firing back with Gemini 3 Pro, fascinating research on AI consciousness that actually provides testable frameworks, and a bunch of interesting developments across the industry.
The big theme I'm seeing is that we're moving from incremental improvements to more fundamental capability jumps, both in terms of what these models can do and in our understanding of how they work.
And the speed of development seems to be accelerating. When you have major companies launching competing flagship models within hours of each other, we're clearly in a different phase of the AI development cycle.
It's exciting, but it also reinforces how important it is to stay on top of these developments. The landscape is changing fast enough that what was cutting edge last month might be baseline capability by next month.
For sure. And as these models become more capable, the applications are going to get more sophisticated too. We're probably going to see a lot of creative uses that none of us are anticipating.
If you're building with AI or just trying to understand where this technology is heading, now's definitely the time to be paying attention.
Absolutely. Thanks for listening to Semper AI Digest. If you found this useful, share it with someone who's also trying to keep up with the AI world.
And make sure you're subscribed so you don't miss the next episode. There's always more happening in AI than we can possibly cover in one show.
Until next time, keep learning, keep building, and stay curious.
See you soon.